Let's now do a very complete visualization and also tracing of object creations. And I would like to run the tracing side by side in parallel between the debugger and also the iPad. So that may be the best way to really reinforce your understanding. So what I would do is I already put a breakpoint, line number 9. So let's now launch the debugger from the Eclipse side, and then I'll switch to iPad, and then to see do the next step over there, and then I'll switch back and forth. So I will right click on the member app2 and debug as Java application, and then let me switch to debug perspective. So now I'm in line number 9, right before I try to create a member for Suyang over here. And let me now switch to iPad. So I put the two relevant classes right now side by side, and also I got my computer memory over here. So this might be the only occasion where I'm gonna pretty much like how I visualize the array. So I would like to show you exactly, well, as precise as possible about how the objects are being created and allocated for space in the memory, and also about the addressing issue over there. So I'll do that only for this particular instance, and then later on, when we actually trace other OO program, I'm going to use a more abstract notation, which I'll show to you later on in the video. Okay? It's really important for you to notice the following. Whenever you declare a new class yourself, for example, member, so this is for defining a new template. From this particular template, you basically define the structure for every instance or every objects that can be instantiated from this particular class. For example, you can see, so this will define the structure for your every member objects. So that's really important to highlight this point right away. Okay, so this part over here really define the structure of your every member objects. So these are the attributes, but they at the same time defining the structure shared by all member objects at the runtime. Whenever you create a new member object, it's always going to have the same structure. All right, that's the first point I'd like to point out over here. And then we actually got two constructors over here. We got either the constructor taking no parameters. We got another constructor version 2, which will take ID, type, and also balance over here, right? And whenever you want to create, you want to make use of this template here, you can define console application, or you can also define JUnit test, right? So these are the two use cases. Later on, when we show to you how to build mobile app, you can also try to create objects when you're creating your app, right? That's something we'll get into maybe later. So I call them instance creation over here. You can create as many instances or objects as you like, right? So when I say instance, I really meant objects, right? So I might just use these two terms interchangeably. Okay, so instance over here, I really meant objects. So you can think about this synonym to each other. Okay, and then you can see we got two object creations. We got new member here, and also we got new member here. Apparently, we're calling the same version of member over here, which I'm going to trace together with you. All right, so that's about these two classes, how they are put together. So they're really related to each other. It's really important for you to realize the relationship. Okay, so now what I would do is I'm going to trace these two object creations and then show to you what's going to be the effects on the memory. Okay, let's do line by line. So what I would do, let's try. You can see, let me make this bigger for you. We're going to print something to the console. That one's easy. So I'm going to focus on only these two lines about object creation. Okay, so the first line, we're going to execute this line over here. So imagine that if the debugger actually pause over here, right? And then what we want to, so you can think about this particular assignments over here. So you got the left hand side declaring the variable. You got the right hand side about using the new keyword, and also you got the middle part about assigning something from the right hand side to the left hand side, right? You got three parts over here. Let's now do part by part carefully. Okay, so I would suggest the following sequence to explain to you. Okay, we're going to look at exactly how this part is going to be executed. So this will be the right hand side. Okay, you can think about this as number 1. Okay, in terms of the execution order, number one. So how is number one going to be executed? We're going to step into, right? So if you remember what we did before, so back to the debugger over here. If I say step into, I'm going to step into this particular version of the constructor that will take actually 3 inputs, integer, character, and also double, right? So now if I say step into over here, I'm going to now step into this particular member. So that's exactly what we did in the previous video. Let's now see the correspondence on the paper. Okay, so now imagine that if I say step over at this point over here, what that would do is actually going to refer to this version of the member over here, this version here. That's what we're going to execute. Specifically, we're going to get 1, 2, 3, 4, 5. So every occurrence of ID over here is going to be replaced by 1, 2, 3, 4, 5. Similarly, the ID over here is also going to be 1, 2, 3, 4, 5. Remember, the ID over here is really referring to the ID over here is really referring to the ID over here rather than the ID over here, right? So I'm going to show you in the diagram in a moment. Okay, and similarly, we also got the input character silver type. So that means every occurrence of type for this invocation is going to be replaced by character S. Okay, so type is going to be replaced by character S. Finally, also 100.0, we just go by position. So every occurrence of balance is going to be replaced by 100.0. So balance over here, 100.0 over here. So that's basically what we have done so far. And then we're going to execute this statement here. And one more thing, very important to note, which is got similar concept, which we discussed in the array. Whenever you're using a new keyword, so that means you're going to allocate some space in the memory, right? And remember before, if you got an array of integer, so that means you're going to have like a 4 bytes offset for the addressing, right? Because each integer will take 4 bytes. We don't really need to go into this much detail for object creation because you can see storing one integer will take 4 bytes. Storing a single character might take less space, but storing a double might take maybe more than 4 bytes, for example, right? We don't really need to get to that technical details. But as far as this is concerned, all you got to know is whenever you see the new keyword over here, followed by the new keyword here, if there's a class name, so that means we're going to create an object. We're going to allocate some space in the memory. And then exactly how much memory it should be allocated depends on the structure of the objects. And the structure of the objects is determined by the list of attributes we just declared over here, right? That's the main lesson to learn over here, right? Since we know there are exactly 6 attributes over here, so that means we need to allocate like a memory space with all the 6 attributes to be accommodated, right? Let's now do this precisely. So now for this new member over here, let me just say this. For this new over here, it's really important. The new tells you you're going to allocate the memory. Since this particular structure for the member actually got 6 different attributes, right? You got ID, you got type, you got balance, you got name, you got weight, you got height. 6. So we're going to allocate a memory space over here. So 1, 2, 3, 4, 5, 6. So this will be the memory space for the first objects, right? And then more precisely, let me just be complete over here. So you can think about, we simply go by the order. So that will be ID over here, and also we got type, and also we got balance. Okay, I'll say BAL for short, and also we got name. I'll say N for short, and also we got weights, and also we got heights. Exactly 6 portions, 6 segments in the memory, right? You can see. So you can see the structure is completely determined by the list of attributes you have declared in the class, right? And then what specific value you should store over here depends on how you set it up. Okay. Remember, by default, if you go back to Eclipse, by default they will simply just be 0. So it's exact. So this over here, since now we are currently talking about creating this particular object, so you can think about this is this. Okay. So the this that you see in Eclipse is simply over here. It's referring to this particular part of the memory. That's really this. Okay, by default, they simply just start by assigning all the default values for each attribute. So it'll be 0.0, 0.0, etc. Right? We have seen this already. So let me put it here. So ID will just be 0, and also type will just be nothing. It's a character. And the balance will be 0.0. The name will just be null. And also the weights will be 0.0. The height will also be 0.0. Right? That's the default value. Okay? So this is only the consequence of calling the new keyword over here. And then how do we override certain attributes by the customized constructor? I'm going to do it now. So let's now execute this line over here. So when we say this.id, remember we already said since currently the context objects, so that this is really the context objects, whatever objects that we are speaking about right now of creation. And the blue one is really not the context object. When we create the second objects, the context object will change. But for now, it's the this is really referring to the blue objects. So we are saying the ID of this blue objects, which is referring to the ID over here, should be assigned to 1, 2, 3, 4, 5. That means we're going to override it by 1, 2, 3, 4, 5. Hopefully you're still following me. All right. And then similarly, when we go to the next line, step over, so this is still referring to the blue objects. The type of that is going to refer to this particular segment of the memory. And then we're going to say S over here, and then that one is going to assign to S over here. So you can think about the dot. So when I say this dot ID, right? So this is really referring to the context objects. And then the dot over here, you can think about is really you can think about in English words like of, right? The ID of this particular context objects. So ID of this context object will be this ID over here, right? Okay. And then finally we're going to execute this balance, which is referring to the balance over here, is going to be 100.0. So this will be 100.0. Okay, so this is exactly what we saw from the debugger, right? Okay, so I'm just going to say step over, step over, step over, step over. After this, you can see 100.0. We got S for the type, and also we got 1, 2, 3, 4, 5, right? That's what we saw from the previous video. And then we can simply say step over. So now we are back. So now when in the debugger, we are right at the end. Right after creating this new member over here, and then as soon as we say step over, what's going to happen is, think about what's happened here, right? So what we have done so far, let's be careful, right? Before I do the next step, what we have done so far, we simply invoke this version of the constructor from member, which is over here, with the input value which I just illustrated. And then we simply got this part of the memory allocated, and now all the value have been set up. However, there is no connection between this variable Suyang and also the starting address for this particular object. There's no connection just yet. Okay, so what's going to happen is we're going to see, first of all, when you declare member Suyang over here, so this will be the second part I would like to talk about, right? So member Suyang, so this will be number 2. Okay, so the number 2 over here is we have got Suyang as a variable, like a placeholder. So this would be Suyang. So what can we store inside? Okay, the fact that you declare Suyang to be of type member, you're really saying, so here member is any address of object type member. Okay, so whenever you declare, let me just be more precise over here. So whenever you declare member and then some variable, let's say Suyang over here, so you're basically saying Suyang can only store any address, and the address must be the starting address for some member objects. So for example, this object over here is a possible object of member type, which we just created, right? And what's the address now? So let's see, according to Eclipse, right? And then after we get the address, we can assign this new assign the address of this object here into this particular Suyang variable. Okay, let's see what's going to happen. If now I say step over, so now if I click on Suyang over here, you can see this is the address over here. Okay, let me just copy that very quickly, and then I will switch back. Okay, let me copy that quickly. So it's 4232. 4232 C52B. C52 and then B. Okay, so now I just copied the address over here. You can see this is the address over here. You can think about this is starting address for this particular object over here, right? This is the object that we are talking about. And then, so what we can store in Suyang is basically this address, 4232, and then C52B. So this is basically what we store in Suyang. Okay, let's now recap very quickly. When you look at this line over here, when you say member Suyang equals new member and whatever input value, right? Break it down into three parts. Part number one, you're creating a new object over here by calling the relevant version of the constructor. And step number two, you declare some variable, and then here of this particular type, and the type is simply a class name. So that means you're going to store the address of some objects of this particular class type. Okay, and then number three, which I can write it down. So this will be number three, which will be to store the address of the new objects into this particular variable, which is exactly what I just did over here. All right. This will be one way to see it. So that's really what's happening at the hardware level, as close as I can explain. Okay. But you can think about conceptually, Suyang is also pointing to the beginning of this particular objects. So this would be very, this is actually very similar to how I explained creating new array objects. So this will be the after view I would like you to have, right? So later on when I trace any OO program, so the pointer is really how I'm going to write. So think about Suyang is basically pointing to this particular object over here, right? Think about it's storing the address, but at the same time, visually speaking, it's really pointing to this particular memory region. All right. Okay, so that's about this particular line, just this line I have just explained. And then I'm going to do the second line faster, but it's still really important to really go walk it through thoroughly. Okay, what about the second one? The second one here, let me use a different color. So we are still declaring another variable called Una over here of the same type member, meaning that the structure is going to be the same. Okay. And then we're going to use another keyword over here, and then we're going to call member. Okay, so we are calling the same version of the constructor over here. So that means we're actually going to use this member constructor here again. Okay, and then so now it's going to be 1, 2, 3, 4, 6. So now every occurrence of ID is going to be 1, 2, 3, 4, 6. Right, so it's going to be 1, 2, 3, 4, 6, and also the second input will be character B for bronze member. So it's going to be B over here. And then the balance will be 200.0. So it's going to be 200.0. So it's going to be over here, 200.0. And notice one thing. What is this right now? Since we are now executing this particular line, so the context objects, the context object is really referring to whatever object we actually allocates for this particular line. Let's allocate a memory. Okay, let's do it here. So there should be exactly the same structure over here with 6 different segments, right? So let's just follow the same order. It's going to be ID, and then type, and then balance, and then name, and then weights, and then heights, right? So what I will do is I'm going to write ID, and then the type, and also the balance, and also the name, and also the weights, and then the heights, right? So that's the second object we're creating. You can see it's distinct portions of the computer memory. Okay, and then by default it's simply just going to be similar. It's going to be 0 here and nothing for the type, and then 0.0 and null for the name, and also 0.0, 0.0. Okay, something like this. Okay, All right, and then so this will be the part for just this part, just about creating this particular new objects, right? And then we're actually going to execute line by line for the constructor. So let's execute this line first. So now this .id, so this is now really referring to this particular object, right? You can see that's the this. Okay, so what I can do is I can simply go back to Eclipse. Remember, we simply step over and then we can step into if you wish. If now I step into, you can see this right now is really referring to balance, heights, ID, name, type, and weights, and they are all of default value because we haven't really overwritten. We haven't really overwritten the values just yet by executing the constructor. Okay. One thing to note: if you click on this, it also shows to you this address over here. We can also put it down right away. This address will be assigned to UNA reference variable in just a moment. Okay, so let me just copy that onto my iPad. So that one there is let's say 1877, and also AB81, AB81. Okay, so now you can see, so this is the address that eventually we will store into the UNA variable, right? So that's just the address I copied that down, right? Okay, so now let's go on. We are going to execute, first of all, how do we execute this line? So this is referring to this object over here. So what about this.id? So this.id will be referring to the ID over here, and then we're going to assign 1, 2, 3, 4, 6 to it. So 1, 2, 3, 4, 6 to it. And also, this.type is going to be assigned to B. So this.type is referring to the type here, and then assign character B to it. And also, this line here, the balance will be 200.0. So the balance will be overwritten by 200.0. Okay. So now, one thing very important for you to know. Okay. You know what? Just okay. So here you can see. Let's compare these two objects over here. Okay. Let me now be very precise about what I'm going to observe. Think about the blue objects over here in the memory, and also the pink objects in the memory, right? We got two objects over here. We got the blue objects and also the pink objects, right? Structure-wise, they are identical. Both of them got ID. Both of them got the type. Both of them got the balance. They also got name. They also got weights. They also got heights. So they have the same structure. Okay, so that's number one. These two, they have the same structure. Number one. However, number two, which is even more important, number two, they actually got so-called instance-specific values. Okay, let me put it down. Instance-specific values. Instance-specific values. What I meant by was, for example, if you take, let's say, ID, for example, both of them got ID. However, their ID values are specific to the objects or the instances, right? ID here, you can see one is 1, 2, 3, 4, 5. The other one is 1, 2, 3, 4, 6. Both of them got type. However, one is S, the other one is B. Both of them got balance, but one of them is 100.0, the other one is 200.0. So it really depends on the instances. So it's really important for you to remember these two observations. Every objects that's created, all the objects created from the same class, they will have the same structure. However, in general, they will have instance-specific values. It's really important observation. All right. All right. So after this, we're going to, after executing this constructor over here, we are simply going to declare UNA over here. Let's declare that. So let me put the variable here. Oh, sorry. Let's draw it better. So this will be for UNA over here. What can we store? So since you declare UNA to be of type member, so that means UNA can store any address. Let me emphasize, it can only store address. Any address of type member. Okay, so apparently this is possible, right? So I'm going to store this particular address over here. It's simply 1877 AB81. I believe that's the address, right? So that's the address. However, visually speaking, if you think about UNA variable simply store the address, that's one way to think about it. But I would say it's more convenient to think about, let me use here. You can think about UNA is really pointing to this particular object over here. You can think about that's what's really happening here. Let me just draw a little bit better. You can think about UNA. I'll try to just not to cross too many lines over here. You can think about UNA is really pointing to this particular object over here, pointing to that. And then let me just highlight it. Okay, and we're gonna use this this particular visualization. Suyang is pointing to this object over here, and Yuna is pointing to this object over here. Basically, so these are two distinct objects that's in the memory, right? Okay, and let's go a little bit further. Of course, after this, if I just step over again, step over, that's exactly what I just traced. Okay, and then if I say step over again, you can see Yuna over here also store the address, right? Which we just showed to you, right? So now you would know if I try to compare Suyang equals Yuna, right? Let's think about what's going to happen here. So you can see Suyang and also Yuna, they definitely store these two values for the addresses, so they are different. Visually speaking, Suyang is pointing to this object over here. Yuna is pointing to this object over here. Are they pointing to different portions in the memory? Yes. So that's why they are pointing to they are storing different addresses. Okay. Let me write it down briefly over here. So now, if you say Suyang equals Yuna over here, it's going to be false because these two addresses are simply different values. Number one. Number two. Suyang is pointing to this object over here, whereas Yuna is pointing to this object over here, which is a different object in the memory. So that's really important for you to understand why. Now, actually having this expression over here is going to give you false, right? We already explained that intuitively from the previous video, but now you can see precisely why it is the case. All right. I think it's quite a thorough tracing to really show to you what's really happening when you are actually trying to write a new use the new keyword to create maybe one object or multiple objects. Whenever you do it, it's going to allocate different parts of the memory, and then the variable only stored just the address over here. So that's why you may compare the address to make sure to really determine whether these two variables refer to the same objects, or if they store the addresses of the same objects. Either way, right? It's really important for you to see eventually what we end up having is Suyang conceptually is pointing to somewhere in the memory, and also Yuna is also pointing to somewhere in the memory. When you see I visualize about method call, I'm going to use a much more abstract way of drawing the objects that's been created.